Hi guys, I wanted to make a video of one of a really good proof question from homework that I got a question about. This is page 301, number 22. And I'm just going to redraw the diagram here. It says there's a trapezoid, ABCD, and labeled like this. And the diagonals intersect at E. Oop. Messy, but hopefully visible. Now, this says if AB equals 2/3 of DC, so that top parallel side, that vector would equal 2/3 the length of vector DC, and obviously they're parallel in trapezoid, so they would be collinear vectors. We want to prove that AE equals 3/5 AB plus 2/5 of AD. And there's a bunch of different ways to go about it. I kind of fiddled around with it a little bit today, and I think I found a pretty nice clean solution, but it does definitely take some thinking, and this is a different kind of proof than you guys would have been used to seeing. We're not really necessarily proving left side equals the right side, or that may not be the easiest way to go about it. I would not necessarily start with AE as left side and the right side as the right side, but I think I'm going to do a different type of proof where I'm going to just start with something that I know is true and rearrange a true statement into what it's given that I want to be able to prove here. So I want to be able to prove that, but instead of kind of doing a left side, right side proof, I can take a true statement. So start with something true. This is a valid way of doing a proof. And then we're going to do good math. If the math that you do is wrong, the proof will not work. So end up with what we want. Okay, so that's kind of what my goal is. I'm going to just kind of start with something that's true and do a bunch of math that's correct, and then I want to end up with that thing there. So I'm just going to duplicate this so I don't have to write everything out again, because that's actually a pretty important thing to kind of recognize. This is a different type of proof. And I'm not saying that you couldn't do a left side, right side. You probably could, but it's not necessarily the easiest way, because it's not necessarily like intuitive with what we would have to do here. So the first thing I want to do is list some of the stuff that I'm given. So I know that I'm given that AB is 2/3 of DC. And that's important, that's good. That also means that DC is 3/2 of AB. And you'll see in a minute why that's important. Okay? We can apply similar triangles to this because we know we've got some Z patterns, so that would be equal angles, and these B and D in there would be equal, and of course those opposite angles are equal. So we know that those two triangles are similar, so we can actually also say, because of similar triangles, that we would know that this vector, AE, would be 2/3 of that vector, EC, because those are equivalent sides on the similar triangle. Not equivalent, corresponding, sorry. So vector AE, because we have that information about these kind of base sides of our similar triangles, that we would have AE is 2/3 of EC, and then also correspondingly EC would be 3/2 of AE. Just because that's kind of what we're trying to prove here, right? We want to get some information about AE. So I know I want to prove something about AE, and I have information about, so I have information about AD. AD is in my, that's in my statement I want to prove, and AB. And I want to kind of prove something about AE. So I'm going to make up, and maybe this is not like the most intuitive, but it's the one I saw. I'm going to make up something that's true. So I'm going to state a true fact. And I'm just going to kind of make a cycle that I know something about. And I'm going to go AD to DC to CA. So around this triangle there. And I'm getting kind of messy here. And I know that that's actually going to equal 0. So AD, because I have an AD in my proof, plus DC plus CA equals 0. So I know I kind of like this because the AD is involved in what I'm trying to prove. The CA is not quite, but it kind of includes that part of that AE side. And the DC, again, is not quite, but it kind of includes, it's a ratio of that AB. So I'm hoping that I can do some good substitutions. I would not want to go anywhere near, like necessarily that BC side. I would try and stay pretty far away from that if I could, because that's not involved, and it could be hard to get something kind of corresponding over there. But I'm going to kind of keep going here, and I'm going to substitute in what I know about DC. And I know that DC is 3/2 AB. So this is AD plus 3/2 AB. Don't forget your vector signs. So that looks kind of like where I'm going, doesn't it? I've got something about AB and something about AD. Now I just need to make that equal to something about AE. So I'm going to take this, because CA is kind of related to AE. It's collinear with that. It's a multiple of that. So I'm going to bring that CA over to the other side of my equation. And I don't like that it's negative CA. I'm going to make that positive AC, which is actually better because I have AE. So AD plus 3/2 of AB equals AC. Now I want to get this in terms of AE. I need an AE there. And this is getting super messy on this diagram, but hopefully you guys can follow it. If I have AC, that's actually AE plus EC. So I'm going to substitute that in. So AD plus 3/2 AB equals AE, which is good, that's what I wanted, plus EC. But what do I know over here? Back here, I knew that EC was 3/2 of AE. So I'm going to substitute that in for EC. So AD plus 3/2 of AB equals, whoops, equals AE plus 3/2 of AE. So now I have kind of like terms. I have multiples of this same vector on the right-hand side. So I would combine those together. And I think the most kind of like flummoxing part of this was seeing those 5s. But now we've got like 2 over 2 AE. So we have 5 over 2 AE. And now you guys might be kind of seeing this and having like a bit of an aha moment here, because we wanted to get a 5 on the denominator. And how the heck would we do that? We didn't have 5s anywhere, but now we do. So I'm going to take this and multiply all of the terms here by 2/5. So everything times 2/5. And that would give me 2/5 AD plus, the 2's will cancel there, 3/5 AB equals, and the 5 over 2 and 2 over 5 cancel, AE. So there we've got it. I guess it's a different order, but that's okay. So AE equals 3/5 AB plus 2/5 AD. QED. So it's a little bit of a different kind of proof, much different than what you're probably used to and what you've seen in previous math courses, but it's absolutely a valid thing to say, I know this is true. These are just 3 vectors that make a triangle, so they add up, you went nowhere. All of the stuff I did was true. I referenced the things that I substituted and used, those ratios of those equal sides. I said that I used similar triangles, and I got to something that's true. So if you start with a true fact, do all good math all the way along, and end up with what we are looking for, you have completed your proof.